Now, let's solve some exponential equations. For example, 5 raised to 2x plus 1 is equal to 25. The first thing that we need to do is to change base 25 to base 5. So, 25 is equal to 5 raised to 2. So, we have 5 raised to 2x plus 1 is equal to 5 raised to 2. If the bases are the same, then the exponents must be equal to each other. So let's have 2x plus 1 is equal to 2. After that, we combine like terms. The constant on the part of this equation will be moved on the other side. So this will become 2x is equal to 2 minus 1. We change the sign from positive, it will become negative. Then let's simplify. So 2x is equal to 2 minus 1 is equal to 1. Then divide both sides by 2. So the answer is x is equal to 1/2. Now let's have another example. Let's say we have 3 raised to x plus 2 is equal to 9 raised to 2x minus 3. Now, we're gonna change 9 into base 3. So 9 is equal to 3 raised to 2. So let's rewrite. So 3 raised to x plus 2 is equal to 3 raised to 2 times the exponent 2x minus 3. Now we need to multiply this one to 2x minus 3. So this will become 3 raised to x plus 2 and equal to 3 raised to the product of 2 times 2x minus 3. So 2 times 2x is equal to 4x. 2 times negative 3 is equal to negative 6. After that, since we have the same bases now, we equate the exponent to one another. So x plus 2 is equal to 4x minus 6. Then, in order for us to get the value of x, we need to cancel x here and the constant on the other part of the equation. So we're gonna get the inverse of both. So we're gonna subtract negative x here and we're gonna add 6. The same with the other part, negative x plus 6. So the answer is equal to negative x minus x is cancelled. 2 plus 6 is equal to 8. 4x minus x is equal to 3x. Then negative 6 plus 6 is 0. So we cancel. Now let's simplify. Divide both sides by 3. So the answer is x is equal to 8/3. For our third example, let's have 8 raised to 4x minus 12 is equal to 16 raised to 5x minus 3. Now, we need to make the bases the same. So we have 8 and 16. We need to find the bases for both. So we have 8 and 16. Let's try 2. So 2 raised to 3 is equal to 8. 2 times 2, 4. 4 times 2 is 8. Now, for 16, we have 2 raised to 4. So 2 times 2, 4 times 2, 8 times 2, 16. So let's rewrite. So 8 will become 2 raised to 3 times 4x minus 12 is equal to 2 raised to 4 times 5x minus 3. Since the bases are the same, we need to distribute our exponent. So we have 2 raised to 3. I should say 2 times 3. 2 raised to 3 times 4x is equal to 12x. 3 times negative 12 is equal to negative 36 equals base 2, then get the product of the exponents. So 4 times 5 is equal to 20x. Then 4 times 3 is equal, negative 3 is equal to negative 12. Now, the bases are the same. We equate the exponent with one another. So we have 12x minus 36 is equal to 20x minus 12. Now, we need to cancel this one and this one. So we add negative 12x, and since this is negative, positive 12 on both sides of the equation. So negative 12x plus 12. So 12x minus 12x is 0. So negative 36 plus 12 is equal to negative 24. 20 minus 20x, I should say, minus 12 is equal to 8x. Then negative 12 plus 12 is cancelled out, simply 0. So now let's simplify this by dividing both sides by 8. So the answer is negative 24 divided by 8 is negative 3. 8 divided by 8 is 1, so we cancel. It will become x. So the final answer is negative 3 is equal to x, or x is equal to negative 3. So when we say inequalities, we are using the symbol greater than, less than, greater than or equal, or less than or equal. Now, let's have this example. Let's say we have this. Consider this. 2 raised to x plus 1 is greater than 32. Now, we do the same with the exponential inequalities. We need to make the bases the same. So, since 2 is in its simplest form, we need to make 32 on the base 2. So, 32 is equal to 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 to the 2 raised to 5. Now, after that, let's rewrite. 2 raised to x plus 1 is greater than, 32 will become 2 raised to 5. Now, when the bases are the same, then let's do this. X plus 1 is greater than 5. Now, after that, we move the constant on the other side of the inequalities. So, we have x is greater than 5 minus 1, which is x is greater than 4. 5 minus 1 is equal to 4. So, for this one, our solution consists of of number, I should say, that is greater than 4. So, let's prove this. So, what are the numbers greater than 4? So, let's say we have 5. How about numbers that are lesser than 4? So, let's say we have 3. Now, if we're gonna substitute this on the original equation, we must prove the inequality. So, let's have the first one. Okay, let's say I'm gonna use 3 first. 2 raised to 3, we're gonna change x by 3. So, this will become 2 raised to 3 plus 1 is greater than 32. Now, 2 raised to 3 plus 1 will become 2 raised to 4 is greater than 32. 2 raised to 4 is equal to 2 times 2, 4 times 2, 8 times 2, 16 is greater than 32. And this is not correct. So, let's try the other solution, 5. Now, 2 raised to 5, we change x by 5 plus 1 is greater than 32. Now, 2, then raised to 5 plus 1 is equal to 6 is greater than 32. Now, 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. Is greater than 32. Now, we get the correct solution, for our inequality, 2 raised to x plus 1 is greater than 32. So any numbers that is greater than 4 is part of the solution. Okay, for our final example, let's consider 2 raised to 3 is lesser than 2 raised to x plus 5. Since the bases are the same, we proceed on solving our inequalities. So, copy 3 is lesser than x plus 5. Then, of course, we isolate 8 by moving our constant on the other side of the equation. Since this is positive, it will become negative. So, 3 minus 5 is lesser than x. 3 minus 5 is equal to negative 2 is lesser than x. Okay. So, let's have negative 1 and negative 3 as our solutions. So, let's have negative 1 first. Substitute negative 1 on our original inequality. So, we have 2 raised to 3 is lesser than 2 raised to negative 1 plus 5. Which is 2 raised to 3 is lesser than 2. Negative 1 plus 5 is 4. 2 raised to 3 is equal to 8. And 2 raised to 4 is equal to 16. That is correct. Now, how about negative 3? So, 2 raised to 3 is lesser than 2 raised to 3 plus 5. And negative 3 plus 5, I should say. So, we have 2 raised to 3 is lesser than, I should say, 2 raised to negative 3 plus 5, which is equal to 2. Now, 2 raised to 3 is equal to 8. And 2 raised to 2 is equal to 4. And this is not correct. Therefore, this is one of the solutions of our equation. So, we need to consider this. Okay, for our activity, I want you to solve the following. Okay, number 1. Let's say we have 2 raised to 3x minus 1 is equal to 8 raised to x plus 2. Number 2, let's say we have 3 raised to 2x plus 5 is greater than 9.